The last factoring method that I will review with you in detail is how to factor a difference of two squares. This is really the only one that has a kind of formula associated with it. So in general, if you have something squared, which I've got here as x, minus something else squared, which I've got here as y, then this really nicely factors into the product of x plus y times x minus y. In order to recognize when we have a difference of two squares, we have to first have two terms so that we have a difference of two things. And then also we need to be able to recognize when we have something that is the result of squaring. So one thing that's helpful is to be able to recognize numbers that are perfect squares. So here's a list of numbers that are perfect squares. You can find these just by squaring each of the numbers. So 1 squared is 1, so 1 is a perfect square. We've got 2 squared, which is 4, so 4 is a perfect square. 3 squared is 9, so that's a perfect square. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64, 9 squared is 81, and of course 10 squared is 100. We could keep on going, 11 squared, 12 squared, but knowing these kind of smaller perfect squares can be a good indicator, if you have a two-term polynomial that has one of these numbers in it, it's probably a difference of two squares. So in the first example here, we have the polynomial 16x squared minus 25. So first of all, we have a difference of two things, and we've got these numbers 16 and 25 here, and so those are both perfect squares. So this is going to factor using our difference of two squares formula. We should first check that there's no GCF to take out, and 16 and 25 have nothing in common, so of course there's nothing to factor out there. You do want to think of what is 16x squared, like what is being squared here? So we want to be able to write 16x squared as something in parentheses squared. Well, you'll just find out what is the square root of 16, that's 4, and what is the square root of x squared, that's of course x. So 16x squared is the same as parentheses 4x whole thing squared. Now 25 is of course 5 squared. So when we factor this, this can just help us to see like what is the x and the y here, because that's going to help us build our factored form using this formula. So here in place of the x, we've got actually 4x, and here with the y placeholder, that's a 5 in this case. So this polynomial is just going to factor into 4x in the first part of the set of parentheses. Then we have a 5 in the second part of the parentheses, and then one of them gets a plus and one of them gets a minus. And it's as simple as that. These are my favorite things to factor because they're nice and symmetric, and also it's really fun to factor them. Now, to give you an idea of why this formula works, rather than memorizing things in mathematics, particularly calculus, it's definitely easier if you understand the why behind everything. So the reason that something like this will multiply into this nice difference here is because if you were to FOIL out this product, we would get first x squared, outer minus x times y, inner plus x times y, and then last minus y times y, which is y squared. And these middle terms here, you can see they just cancel out. And what you're left with is just the first thing squared minus the second thing squared. Okay, in example 2 here, we have the polynomial x to the fourth minus 81. Now 81 is a perfect square. X to the fourth doesn't look like it's anything squared, but if you just consider that if you square x squared, then that gives you x to the fourth because you'll multiply those exponents together. And of course, 81 is 9 squared. So this is actually a difference of two squares, the difference of x squared squared minus 9 squared. So when we factor this, the x squared is playing the role of just the x. I know it's a little confusing. Remember that x is just a placeholder here. So in our set of parentheses, in the first part, we will have an x squared and an x squared. And then in the second part, we will have a 9 and a 9. One of them gets a plus, and one of them gets a minus. Doesn't matter which order you put these in. I'll probably switch it sometimes, but using this formula, we will have a plus in the front and a minus in the second. And we always want to make sure that we factored all the way. Here we have a sum of two squares. 9 is actually a perfect square itself, right? This is 3 squared. And then over here we have another actual difference of two squares. We've got x squared minus 3 squared. So the sum of two squares cannot factor further, but a difference of two squares of course can. So x squared minus 9 is going to factor one more time into x plus 3 times x minus 3. Then once we get to x to the first power, that's called the linear factor, and that is as far as you can break something down in terms of factoring.